going soon. Aha, it's live. Okay. No? Okay. Aha, it's live. Okay. No? Alright. We have... Think we can turn off the lights or something? Aha, it's live. Okay. No? Alright. We have... Think we can turn off the lights or something? Aha, it's live. Okay. No? Alright. We have... here... Think we can turn off the lights or something? Is that readable, the font? No. Alright. You cannot read it? We have here. Think we can turn off the lights or something? Aha, it's live. Is that readable, the font? No. Alright. You cannot read it? We have here. Think we can turn off the lights or something? Alright, so we are streaming live and ready to go. So let's you cannot read it? Let's go. If I can get the presentation. Alright. Okay, so welcome everyone. You're gonna have to excuse me because I'm going to sit down. So we are streaming to capture the audio of the stream and ready to go. But I think it will be okay for the presentation. You cannot read it? Let's go. Okay, so I can get the presentation. Right. Few new faces. Okay, so welcome everyone. How many people? You're gonna have to excuse me because I'm going to sit down. So we are streaming to capture the audio of the stream and ready to go. But I think it will be okay for the presentation. How far have you gone? How many people have used Docker Compose? Few new faces. Okay, so welcome everyone. How many people? Anybody tried already? Use down. So we are streaming capture the audio Docker ready to go. But I think it will be okay for the presentation. Just one person. How far have you gone? How many people have used Docker Compose? As far. Few new quite far. Okay, so welcome everyone. How many people? Alright, so I'm going to give a presentation which is loosely based on the Docker for Developer presentation from GPSW. How far he did one this presentation. I think last year I've made a few changes as there are new things. Alright, so I'm going to give a presentation and all the based on the Docker for Developer presentation from GPSW. Copyrights, whatever. So he did one this presentation. I think last year what is Docker? So there were a few people that did right. So I'm going to give a presentation and all the based on the Docker for Developer presentation. Okay, so to give a history about where Docker comes from, initially there was a company called VXLAN, which was there were a few people that did right. So I'm going to do a presentation and they providing you with the tools to easily. Okay, so to give a history about where Docker comes from, initially they automatically called what is Docker, which was there were a few people that did right. So I'm going to provision the presentation and they providing you with the tools to it was built to give a history about where Docker comes from, which was automatically with the Docker, which was there were provisions of 2008. However, provision was based on the union file system and providing you with the tools to later. It was built with a specific union file system that was purely willing to deviate was automatically. So their first version had a lot of problems. It required custom versions to be compiled. They Union provides visibility for all the patches they were using. It was a specific unit that has many policies, so they wanted to do a rewrite. And as they were going to do a rewrite, they decided to custom create a single Union provides Immutable that was going to handle it had many configurations, containers, building, images, and they wanted to do a rewrite, put into one and then we decided to custom create. So they started off with just close these, and then that was going to handle these it had many configurations, purely build language, which everyone wanted to do a rewrite. And Windows was and then we decided to create. So they started off with just close these, and then that was going to handle download the binary, it had many purely of course I'm online, which everyone wanted to do a rewrite. And Windows was and then we decided to find Docker. So they started off with just close these, and then okay. So download the binary, it had many of course I'm online, which everyone wanted to do a rewrite. And Windows was and then we decided to find Docker. So they started off with just close these, and then okay. So download the binary, it had many of course I'm online, which everyone wanted to do a rewrite. And Windows was and then we decided to find Docker. So they started off with just close these, and then okay. So download the binary, it had many of course I'm online, which everyone wanted to do a rewrite. Docker Saigon organization. I just updated it on our okay, first thing, so I'm using Konemo, I've already set that up. So of course I'm online. I have all my Saigon organization. I just updated it on our let me move into my local Docker first thing, so I'm using Konemo, I've already set that up. So of course I'm online. I have all my Saigon organization. I just updated it on our let me move into my local Docker first thing, so I'm using Konemo, I've already set that up. So of course I'm online. I have all my Saigon organization. I just updated it on our let me move into my local Docker first thing, so I'm using Konemo, I've already set that up. There are no containers running, all the containers are active already. I have all my Saigon organization. Alright, okay, I'm going to mount my host. I'm using CoreOS on Windows, and I need to mount my hosts. I'm using Konemo, I've already set that up. There are no containers running, all the containers are active already. I'm going to show you that it's much easier. Alright, okay, I'm going to mount that it's possible to do it much easier. I'm using CoreOS on Windows, and I need to mount my hosts. I'm using Konemo, I've already set that up. There are no containers running, all the containers are active already. I'm going to show you that it's much easier. Alright, okay, I'm going to mount that it's possible to do it much easier. I'm using CoreOS on Windows, and I need to mount my hosts. I'm using Konemo, I've already set that up. There are no containers running, all the containers are active. So next, I'm going to show you that it's much easier. Alright, okay, I'm going to mount that it's possible to do it much easier. I'm using CoreOS on Windows, and I need to mount my hosts. I'm using Konemo, I've already set that up. There are no containers running, all the containers are active. So next, I'm going to show you that it's much easier. Alright, okay, I'm going to run while we I'm going to run a little back script that's going to list all the containers that are running. So next, alright, so every half a second it's going to execute a command to get all of the running containers. I'm going to run while we all the time. I'm going to run a see what's going on while I'm doing the little back script that's going to list all the containers. So right now, the first thing we can do is, as you saw earlier, every half a second it's going to execute the command to get all of the running containers. I'm going to run while we all the time. I'm going to run a see what's going on while I'm doing the little back script that's going to list all the containers. So right now, the first thing we can do is, as you saw earlier, every half a second it's going to execute the command to get all of the running containers. I'm going to run while we all the time. I'm going to run a see what's going on while I'm doing the little back script that's going to list all the containers. So right now, the first thing we can do is, as you saw every half a second,
So with Docker info, I see information about what engine I'm using. I'm using 1.9, which is not yet standard release. According to it should be released now. So that's why I want to do the meetup today, because hopefully after today this version is officially released. So with Docker info, right now I'm using CoreOS as my using kernel on my machine. I am registered standard release, logged in. According to my name, it should be released now. That's why I want to do the meetup today, because hopefully after today this version is going to show me my client. But with Docker right now I serve using CoreOS as my. I got these comments. I know Docker is installed. I am registered standard release, logged in. According to my name, it should be released now. That's why. Alright, so let's have a look at how many processes are running on this. It's going to show me my client CoreOS. Right now I serve using CoreOS as my. Because I got these comments. I know Docker is installed. I am registered standard release. So the first thing we're going to do is according to my name, it should be released now. That's why. Alright, so let's have a look at how many processes are running on this. It's going to show me my client. So as you see right now I serve using CoreOS as my. Because I have these comments. I know Docker is installed. I am registered run. I'm enabling the container, and I'm requesting terminal, and I'm running batch. So I'm inside the batch. So as you see right now I serve using CoreOS as my. Because I'm still random. I am registered run. I'm kernel. So run if I do container, and I'm requesting release information, and I'm running batch. So I'm inside the batch. So as you see right now I serve using CoreOS as my. I'm now inside the random. I am registered run. I'm kernel. I can run here if I do container, and I'm requesting release information, process running batch. So I'm inside the batch. So as you see right now I serve using CoreOS as my. I'm now, and we see that there's just one root, the ID which is batch, and then the console run here if I do. So inside this container, only release information, process running batch, and outside I just start. So as you see, 75. I'm now, and we see that there's just one root, the ID which is batch, and that's the first thing that Docker allows here. It allows you to quickly spin inside this container only a new machine, and as you saw it was very fast. And outside I can see that here. I'm now, and we see that I can just currently install root, the ID and 9, and that's the last thing that Docker allows here. CoreOS I can quickly spin inside this container because CoreOS is a new machine, and as you saw it was very fast. And outside toolbox I can image see that because CoreOS is here right now. Docker, so I can just package now root, the ID and 9, and that's the last thing that Docker allows here. CoreOS I can quickly. So that was a DVD. So now let's try, and as you saw it was very fast. And outside toolbox I can image see that because CoreOS is here there. Further Docker, so again I can check the ID and 9, release it, and that's the last thing that Docker allows here. CoreOS I can quickly. So that was a Fedora. So now that's simple, and as you saw it was very fast. RP I can image see that because CoreOS is here there. Further Docker, so again I can check the ID and 9, Fedora, release it, and that's the last thing that Docker allows here. So that was fast. So how fast? That was a Fedora. So now that's simple, and as you saw it was very fast. How long does it take to spin up to manage because CoreOS is here there. Further Docker, so again took about 1 second. Fedora, release it, so that's very fast. So that was fast. So how fast? That was a Fedora. So now that's simple, and as you saw it was very fast. How long does it take to spin up to manage because CoreOS is here there. Further Docker, so again took about 1 second. Fedora, release it, so that's very fast. So that was fast. How fast? That was a Fedora. So now I'm in Ubuntu, and what I'm going to do now, again, about 1 second. I'm going to install a new package inside. That's very fast. So that was fast. Now I'm in Ubuntu, and so this is now downloading a new package. What I'm going to be available in this container, and it's not installed on any of the other packages. I'm going to install. The way this works is that Docker uses that was fast. A special scratch layer or temporary layer while the container is running. This is now downloading a new package that I'm going to be available in this container, and you can then choose to make it once to have done. The way this works is that Docker uses image. It's like taking a special scratch layer or temporary layer while the container is running. This is now downloading a new package that I'm going to be available. So Docker allows us to tag and then share this new container once the installation. The way this works is like Docker. So let's look That was like taking a snapshot, go back to the scratch. So this was the first part of the demonstration, which is how to use Docker to install an application. Right? So Docker allows us to tag already and then share the Docker virtual. The way this works, it's running with Linux inside my Windows. Taking a snapshot, go back to the scratch. So this was the first part of the when Docker releases how to use Docker to install an application. Right? So Docker allows us to tag already and then share the Docker decided the way this cloud and running inside Linux inside my Windows. Go back to the scratch. This was the first part of the when Docker releases and they will deliver service. Right? So Docker allows us to tag already training share and Docker decided the whole code in the cloud and is managed inside Linux inside my Windows. Full and go back to the contribute. This was the first part of when they launched Docker, they came with a tagline called build and ship by training and run any app anywhere. The whole code in the cloud and is managed inside my Windows. Building means that you can package your application inside a container. So we'll look at that part of that. When ship, when they launched Docker, they came with a tagline take that from build and ship by training and run any app anywhere. The whole code in the cloud and is managed inside my Windows. Building means that you can run your app and execute inside a container. So we'll look at that app. Any app that is ship, anything that needs runs on Linux. We can also take Windows Linux and run any app anywhere. But like I said, it's build preview. So now let's say anything that runs your app and execute inside a container. We'll look at that. And anywhere, so you can run it as anything that is running on my local laptop. You can also take Windows Linux and where any app anywhere. But like I said, it's build. I think right now, now let's say anything that runs your app and execute inside a container. And anywhere, so you can run it as anything that is running on my local laptop. You can also take Windows Linux and where any app anywhere. But like I said, it's build. I think right now, the question now, let's say anything that runs your app and execute inside a container. And anywhere, so you can run it as anything that is running on my local laptop. You can also take Windows Linux and where any app anywhere. But like I said, it's build. I think right now, we will see there. Anything that runs your app and execute inside a container. Take a few time. I already played and anywhere, so you can run it as anything that is running on my the question was set this up on the Windows. We haven't created Droplet. It can be they have OS Droplet, or you can use a Ubuntu or Droplet. You have to put set this up on the Windows. We haven't created Droplet. It can be, or you use Docker machine. They have OS Droplet, or you can use a Ubuntu. So we'll see that later. You have so anywhere. So now let's look at how do we build. It can be, or you use images. First word from the tagline. Build. Alright, let's build. So we'll see that package our application inside it. You have so anywhere. So Docker came up with a concept. So now let's look at how do we build. So in the meantime, or use installation first word from the tagline. Build. Alright, let's build. So we'll see that package our application inside it. You have so anywhere. So Docker came up with a concept. So now let's look at how do we at this point, if in the meantime, or use line first commit this image, commit this new container to let's build. So we'll see that. Like I could do a build by manually running my command. So Docker and then committing that container. Now let's look at how at this point, if in the meantime, that's not very grand line. The better approach is I use Dockerfiles. Dockerfiles are like recipes. So we'll see that. They make sure that you can build by manually running my command. So if you and then create a project in the Dockerfiles. But at this point, if it is something that will give it build servers, the build server is I use Dockerfiles. Dockerfiles then are like recipes. That image, they make sure that you can build by manually running my command. So let's first look at Dockerfiles. The concept of Dockerfiles was at this point, if it's very general, you specify what image you will start from, then you specify which command and then and that image, they make sure that you can then you get by manually running my command. So So this is an example of a very concept. So at the first time it's very good to start with your build and specify what image you will start. Then you specify not specify version. It will always take that image. That is going to get that is always the same build. So this is an example of a so it's very important. I think so at the first time it's very good to start with your build and specify what image you will start. Then you specify not specify then always take that because every image that is shipped without any hash. So this is an example. You need first it's very important. I think so. And then you need to install and specify what image that we will see how to specify then because actually because every image that is shipped without any hash. After we have installed we need first it's very important. And then next we inside install HTML and we're going to specify that whatever document is going to run because every image that is shipped. So this is our Dockerfile. Very clear installed what is going to be very important. And then next we inside install HTML and we're going to specify that whatever document is going to run because every image that is shipped. So this is our Dockerfile. Very clear installed what is going to be very important. And then next we inside install HTML and we're going to specify that whatever document is going to run because every image that is shipped. So this is our Dockerfile. Very clear installed what is going to be very important. And then next we inside install HTML and we're going to specify that whatever document is going to read where I'm so this is our Dockerfile. This is the contents of my static web folder. Inside I have a Dockerfile. Inside install HTML and okay, that's the Dockerfile I just read on the screen, right? And I have a picture so this is our Dockerfile. This is the contents of my static web folder. Inside I have a Dockerfile. Inside install HTML and again that's the Dockerfile command right? And I have a picture so this is our Dockerfile. I'm specifying a tag the contents of my static web folder. Inside I be able to reference the image I'm going to build it. And again that's the Dockerfile command. Usually when we and I have a tag we put a repository and followed by I'm specifying a tag the name of my static web folder. Inside I have my username and then the repository which is usually when we and I specify build the current directory and followed by I'm specifying a tag the name of my static web folder. Inside I ran this command before so it went very fast. So basically what happens and I specify building the current directory and then he's running the app update. But because he has already an image before that lists I ran this command. If I don't want him to very fast, I can use what happens and I specify building the current directory and then he's running the app update. But because he has already an image before that lists I ran this command. If I don't want him to very fast, I can use what happens and I specify building the current directory client translation. Then he's running the app update. But because he has already an image before that lists I ran this command. If I don't want him to very fast, I can use what happens and I specify building the current directory client translation. Then he's running the app update. This is the dashboard. But because he has already an image before that lists I ran this command. If I don't want him to very fast, I can use what happens and I specify building the current directory client translation. Then he's running the app update. This is the dashboard. But because he has already an image before that lists I ran this command. If I don't want him to very fast, unfortunately I didn't have so I'm afraid this is the dashboard. I'll try to talk a little bit closer to the microphone. If I don't want to unfortunately I didn't have okay, this time I executed the command with no cache, so this time he's running the app update without actually using the cache. So it's going to take a little bit longer. So as you saw, when you build, talk a little bit, Docker optimizes the build process for you
automatically allows
this
you
time
to
I executed the command with no cache.
reuse
So this time
previous
it's running the app page without actually using the cache. So it's going to take a little bit longer. So as you saw, when you build, Docker optimizes the build process for you. It automatically allows
this
you
time
to
I
executed the command with no cache.
reuse
So this time
previous
it's running the app page without actually
the
build is running, and then once the build is done, so as you saw, when you build, Docker
after we build,
process for you.
we need to ship.
This time
So earlier I mentioned already that there's a concept of repositories. So Docker is running, and then once the build is done, which is similar to the GitHub. It's a public area. So after we build, project we need to ship, where you can create your account. So earlier I mentioned already that there's images to and from. So if you pay, Docker can have private repositories, and then once the build is done, which is similar to GitHub. But by default it's pay. Anybody can have build. So if you need to ship, where you can create your account. So earlier I mentioned already that there's images to if you're working on something. So if you pay, Docker can have private repositories, and then once the build is done, which is similar to GitHub. But by default it's pay. Anybody can have build. So if you need to ship, where you can create your account. So earlier I mentioned already that there's images to if you're working on something. So if you pay, Docker can have private repositories, and then once the build is done, which is similar to GitHub. But by default it's pay. Anybody can have build. So if you need to ship, where you can create your account. So sorry. That's because I was streaming and the YouTube video was playing in the background. And so whatever I was saying was being repeated and then fed back and fed back, fed back with a 10-second delay. So it was like, how many? 20 times me talking across each other. So, all right, that sucks. I think I'm gonna have to find a way to mute the audio later. But now it should be fixed. 10 seconds later, it should be fixed. Okay, so very sorry for that. In the meantime, the build is still running. No. So when you run a container, it's completely new file system, completely isolated from your host. So whatever you have installed, as I showed earlier, when I do the package listing, you see that on my, well, I didn't do a package listing on my host because I don't have a package manager on my host. But normally, if you run Ubuntu, you do a package listing on the host, you will see lots of packages. But if you go in the container, it will be like a almost empty scratch image. So the way the cache works is, as you see here, we will scroll a little bit. Every time a process has finished, it creates a new image. Okay, it tags that image, and then it starts a new container based on the previous layer. So that's what we mean by cache. It uses only a cache as far as the image layers are concerned, the image that is being built. So every image is built of many, many different layers, one across the other, one on top of the other. And yeah, it uses a union file system to see the final image. And every time you make some changes, the new files are written, only the changes are written into the layer. So you get a very compact layer which just stores the changes. So that's the cache that it's actually using. All right. So now I have successfully built a container. So I have a bunch of images here, but I have here my soup web container, which was just built about a minute ago. So now I have under my Docker images, I have this web container built. Okay, so I go back to the repository concept. Once you have a Docker Hub account, so you need to go to the Docker Hub, and you need to create an account. Then you can Docker push your image directly to the Docker Hub. Okay, so if I specify Docker push, and then I specify my container tag, okay, it starts pushing my container to the registry.
Builded image.
The image that I just built, yes. I didn't specify the tag, so it's taking the latest one. Normally I should specify an additional version number to separate the different versions of images that I build. Okay, so let's go to the Docker Hub. Okay, so there is this soup web one that is I created this morning, 8 hours ago, and you can see that there's only a latest tag, which is the image that I just built. It doesn't give me information about when was the last time I pushed it. I guess maybe because because it's not finished yet. So right now it's pushing layer by layer, and once it's completed my push, it will show on the Docker Hub that I have updated the image. Okay. Okay, so that's the Docker Hub, a service provided by Docker. And obviously, when you start using Docker for your company, you would want this to become private. So they hope that you will buy private repository from them, so you can develop. And the Docker Hub allows you to greatly improve your workflow, because it also has the ability to monitor a GitHub folder, a GitHub repository, and as soon as you push new code, the Docker Hub can build a new image, automatically publish it on the hub. So, so it provides a lot more than just manually push and pull. Actually, I didn't highlight this in the PowerPoint. Okay, then another option is, if you want, you can of course you can run your private registry. There is a separate GitHub repository called distribution, and under the documentation there is a deploying instructions how to deploy your own registry. So the Docker Hub is basically a registry with, on top of that, a user interface for people to search and to see information about the tags that are in an image and everything. If you are going to deploy your own registry, for example on your server in the office or within your cloud environment, then you need to take care of your authentication. You're gonna have to take care of the repositories. If you expose your registry to the public, you need to make sure that nobody can start messing with it. So so you can do your own registry server, but it's not necessarily so simple. There are also other registry providers, such as Quay.io from CoreOS, and there are a few others. Tuan, do you know any others? Quay? Does Tutum has a registry? So when you register with Tutum, you have a private registry as well. Yeah. Okay. So you can run your own. It's open source as well. So, okay. So as mentioned earlier, we are looking at the shipping part of this. So we're gonna have to provision a fresh host. Right now, I can go to my DigitalOcean platform, droplets. Okay, and I have created this meetup droplet today. Can I see when I created this? History? Yeah. So about 8 hours ago, I created this as well. So so it's a fresh. So let's go. There's nothing here. I have only one image. So this is a fresh one that I literally, you can go to, as you can see on the screenshot that I took. If you go to DigitalOcean, you select the image under applications. You can select Docker 1.8.3 on 14.04, That's a Ubuntu. That's a Ubuntu image with Docker installed for you, and you don't need to do anything else. I have a lot of other ones here as well. I have CoreOS images, which are very similar. They are just a little bit more. They are operating system that's purely meant for containers. So I like CoreOS more than Ubuntu. Unfortunately, I couldn't make the Swarm work on CoreOS. Okay. So let's go to the. Oh, I didn't finish my. I didn't actually run the container I built on my server. Well, I can do it on the Ubuntu environment. I'll just run it straight here. So I'm now on this Ubuntu server, and I've never run any of this application before. I'm just going to go ahead, and what Docker does is immediately it's going to look for this soup web image, and if it doesn't find it, it's going to start pulling it from the registry. So I built it on my local machine, I pushed it to the hub, and when I run it on my cloud server, it automatically pulls it from the hub. If you use a private registry, then you will need to use a different one. Okay, so right now I have the Docker web that was created 8 minutes ago. Also, if I go to my hub, if I refresh it, you should see that the last push has now updated 5 minutes ago. Okay, so now I can execute the container. Run. Okay, it's running actually, sorry. So right now it's listening on port 32769. So if I go to the meetup.ludino.com, which is the name of my server, and I go to that port, that's my container that I just created. Okay, so that's my container that was running on my that I built on my local machine. Now, I actually should run on my local machine as well. So let's just run it, because I didn't complete my full build demo. So on my local machine, I'm running CoreOS, and on my cloud, I'm running Ubuntu, and I'm running the exact same image on both, and it's working. So if I go to my local host, local Docker, and what's the port? I didn't tell him what port to run on. When I did my Docker run, I specified a capital P. The capital P indicates that whatever ports the container or the image has defined need to be mapped to the host. My host is my local Docker virtual machine. So I need to go to my local Docker virtual machine, and then I need to go to the port that's defined on my local Docker virtual machine. Okay? So let's do a change now. We're gonna make a change. We're gonna change the Docker file. This is not how you would normally develop an application. Obviously, you wouldn't change your Docker file. You would actually change your source code. So first thing I'm going to do is I'm gonna replace this. I'm not a good Vim user, so just gonna copy paste. Okay. I'm also adding an image.
So I'm adding into my Dockerfile a step where he's going to copy the image into. This is a very simplified Dockerfile. I'm not going into the very complicated Dockerfile right now. Yeah. I need to sudo because it's root. How would you do it? Okay, so I'm going to I'm still learning Vim. And this is not proper HTML either. I'm not a... Oh. Is that... That's right? It's not perfect, it's not, but it's okay. So now, if I do the Docker build again, obviously, it's going to be faster because I'm gonna use the cache. So now he's using the cache except on this step because this step has changed. So where this step changes, he re-executes it and he creates a new image. And he's copying the Saigon pictures. And now if I do a new Docker run, okay, so now he created another container, and this one is listening on the next port. So if I go to the next port, all right, nice picture edit. Okay, so what's great about this is that my old container is still running. So if I find out that this new image has an error, I can easily go back, just use my load balancer to balance the traffic to my working images, and I can control my rollout. So that's already a great thing that I get for free with Docker. Okay, so let's continue. I've changed the file. I should have given them a name. Do I need to clean up? Okay, I've already pushed. I've already run it in the cloud. Maybe I want to pull a new one and run it on port 80. So I'm going to log out. I'm going into the cloud and I'm going to run it on port 80. So this time I'm Docker running the same web application. Actually, I should pull the new version first. I haven't pushed it. It's not going to help. It should be fast. So now on my local server, I'm just pushing the newly built image, and then I'm going to pull it, and then I'm going to start it and run it on port 80. So port 80 is going to make it that I don't have to enter the port anymore. Okay. So while it's doing that, let's have a look at anywhere. So the minimum requirement for Docker is to have a kernel above 3.8. Okay, so your operating system needs to have minimum 3.8. In the DockerCon this year, there was Dieter Reuter from Hypriot presented a demonstration of running 500 Docker containers on a Raspberry Pi 2. And then they had a challenge: how many containers can they run? And in October 20, they finished the challenge because they reached the physical limit of 2,500 containers with the current version of Docker. So 2,500 containers running on a Raspberry Pi 2. It was limited because of the number of threads Docker is using at the moment. with the default Go version 1.4, it's written in Golang. So with Go version 1.4, there's a maximum number of threads that is exceeded if you try to go above 2,500 containers. Maybe it's not interesting to most people here, but it's kind of cool that they were able to do that. And they're actually, if they are able to reduce the number of threads that Docker is using, and if they remove the threshold on the Go runtime, then they can run more than 2,500. But for now, they settled on the 2,500 being the maximum. Okay, so that was the first part about building, shipping, running. All right, so let's have a look at the timeline. So after the first version was released in March 2013, then every iteration they're using, every month they release a new version with some new features. So they added first automatic bridging. So when the Docker spins up the container, they automatically connect the container to a bridge. So the container is running behind the network. So you need to expose the ports on the host. That's why whenever I run the container here, if I run the container, I need to specify what port needs to be exposed on the host, because the container is running behind a network address translation. Right? The new image has been downloaded. So let's.
I have a question about previous slide about 2,500 Docker containers.
Sure.
Does it mean that it's all overhead if I use Docker on my server?
That there's almost no overhead. Is that your question?
Yes.
Yes. So the overhead, and we're going to look at the overhead of Docker. Oh, that's not what I want. We're going to look at the actual overhead that Docker has. Just give me 1 second. Okay. So now I'm running it on port 80, so I don't have to specify the port. That's just what I wanted to do. So I think in the next slide I say a little bit about the overhead. So let's look at this first. So the automatic bridging was implemented in one of the early versions. Then they added the ability to expose volumes from the host into the container. So if you have some database, for example, and you need to persist some data, right now if you delete the container, all the data in the container is gone. So if you run a database, you need to store your data for the database outside of the container. And for this purpose, they provide you with the ability to mount volumes. I'm not going to do a demo of that. They added the builder in version 0.4. Another big release here is when they were able to support different storage drivers. Maybe if you noticed earlier, I said that in the beginning there was only support for Debian and Ubuntu because they were using a storage driver or file system called a Union AUFS, a Union File System. This Union File System was not supported on CentOS or Fedora. So when they wanted to support CentOS or Fedora, they needed to support the device mapper, which is a different storage driver. So by introducing the storage drivers, they were able to support all of the standard Linux environments. So they are supporting, as you saw earlier, CentOS and Fedora as well. Then after they added the storage driver, they supported Btrfs, which is another Union file system. Then they added the native exec driver. Before adding the native exec driver, Docker was still dependent on LXC. So you needed to install LXC, Linux container, and then you needed to install Docker. But when they they took all of the parts from LXC and they made their own execution driver, then they could use Docker without LXC, purely relying on the Docker, on the Linux kernel features. Okay. Then they added linking between containers and ability to share the network with the host, because like I said in the beginning, I said it goes on a network, so you have to expose the ports, but sometimes you want these containers to share the same network. Two containers that need to be on the same network interface. They can communicate over local host ports. So they added this ability with the net. They added the ability to share the network of the host operating system. Of course, if you run container on the host operating system, you need to consider the ports that you're going to take up. All right, so then in June 2014, they made it production ready, version 1. After that, they added a lot more features. They announced partnership with Microsoft, where Microsoft was taking the initiative to support the Docker API, as it is a community common API. So it means that you can use a Docker client with a Windows server and with a Linux server. That's what they're working towards. It doesn't mean that you can run the Linux image on a Windows server. No, you can just use your Docker client against a Windows server to run Windows images. By doing this, they're able to provide the same API for all container runtime. After that, in December, at the end of the year of 2014, they announced Machine, Swarm, and Compose. And I will see a little bit of that because that added a lot of very handy features. Then they added, they released a new version of the registry, which is a lot faster, and they started supporting the Windows CLI. Yay for me, I'm using Windows, so thanks to that. Then, in June 2015, they announced more support for plugins. Because Docker started to become more and more taking over the whole ecosystem, people were a little bit upset and decided we want to have the ability to put in our own drivers. Obviously, not everybody wants to use VXLAN. Not everybody wants to use this particular logging driver. Not everyone wants to JSON logging, or somebody wants to Fluentd logging. So once they started supporting those plugins, people were able to develop their own logging drivers or their own volume drivers. So they could, even with the effort to support additional network drivers. So more about that later. And so now they're about to release version 1.9. Okay, so why do containers matter? So providing this platform, this uniform environment for everybody to build images and ship them and run them gives companies the ability to create immutable infrastructure. Who is familiar with the concept of immutable infrastructure? Anyone? So Google it. There's some really nice videos about this. Another presentation from Jérôme Petazzoni is about immutable infrastructure, which is the concept of once a server is live or in production, you're not allowed to touch it, not even if you're going to do an upgrade. If you're going to do an upgrade, you're going to get rid of that server and you're going to take a new server. So the servers that are running are immutable. You're not allowed to touch them. If you're not allowed even to do an upgrade or an update, nothing like that. Okay, so with Docker, to achieve an immutable infrastructure, you need, for example, with virtual machines, you need to have a golden virtual machine image, one snapshot, and then you deploy all your servers from that snapshot. Then, when you need to deploy a new server or a new version, you need to make a new snapshot, and you need to deploy new virtual servers or virtual machines from that snapshot, and then you need to get rid of the old ones. So you never touch a running server. That's the concept of immutable infrastructure. When you have Docker, you can do this very easily with containers. The next thing is Docker really makes it easy for you to do a continuous integration or continuous deployment pipeline. You can link up your GitHub repository with your with webhooks to your Docker hub. So as soon as you push, your repository can inform the Docker build server to build a new container, or to Jenkins, for example, to build a new container, to build a new image, and then automatically run your tests on that image. And then you know that that image that has been built and tested, if you take that image to the production environment, that's exactly the same image. You're not reinstalling the application on a different server. You're not doing any of that. You're actually running the image that has been tested inside production, so you know 100% that that's going to go fine. Another application for Docker is to work with 12-factor applications. 12-factor applications is a concept of for microservices. Anybody familiar with that? Yeah. So if you're not, Google it. If you search 12-factor, there's 12 guidelines that tell you what you need to do to follow this approach. Microservices are a big hype. everybody loves microservices, and it's gone to the point where everybody hates microservices. So people start saying, and which is right, when you are designing from the start for a microservice, you may run into trouble. It's better to do an MVP focused as a monolithic application, which is correctly has correct partitions within it, so you can easily split those off into microservices later. But microservices are very important for very big enterprise environments where you can have multiple teams focus on specific services. So Docker allows to do that very easily because it's polyglot. It doesn't matter what's running inside the container. Can be Node.js, can be Ruby, can be PHP. All of them run together on the same host. There is no conflict of packages versioning because the packages are completely isolated within the images. All right, so that's why Docker matters. Okay, so like I said earlier, you can deploy reliably and consistently, and you are sure that it's the same behavior regardless of version, regardless of distro, and regardless of dependency. All right, so as you see, we talk now about the overhead. It's very fast. I timed it 1 second to spin up a new container. If you run a very simple container, like the minimum requirement is 100 kilobyte on the disk for the scratch layer, and less than 1.5 megabyte memory. The CPU performance is native because the process runs directly on the bare metal. If you run it on bare metal, if you run it in a VM, it just goes through the virtualization. The memory performance, there's a small hit because there's some isolation of the container, so there's some control of what the container can see when it accesses the memory. So the kernel needs to apply some accounting, some control on that. But you can turn that off if you want, if you don't want to isolate that. So if you really want high performance, you can do that as well, but without the isolation. Then on the network and on the disk, there's also a small overhead. I mentioned that it uses a union file system, so that means it's a copy on write system. That means if you start writing to some file, if it's a very big file, it needs to copy the whole file to the scratch layer, then modify the file. So there's a little hit there. If you work with a lot of small files, it can go fast. It depends on which storage driver you use. If you use a union file system, it's very good for small files, but it's painful with big files. If you use Btrfs, it's different. I don't remember exactly what are the pros of every storage driver, but there is a difference between driver. Network, again, we can get rid of the network isolation, or we can use the network isolation, in which case it uses Docker bridges and IP table rules, I would say. Okay, so great, containers. I think by now you understand a little bit more what containers are, how it helps us. So let's compare them to virtual machines. So containers, virtual machines, you have the infrastructure, then you have the host operating system and a hypervisor, and then you have every guest virtual machine has its own OS, because the hypervisor only gives you a virtualized interface to the hardware, right? And inside the virtual machine, the operating system needs to talk to the hardware, the CPU, the memory, the network. So you need to have a whole operating system. The whole operating system needs to boot. They're usually very big, so they're very hard to ship around, right? So containers, as we saw, they are very small. The infrastructure is there, then the operating system, and then the Docker engine. And the only thing that's inside a container are the specific binaries and libraries for the application. And everything else is, it's talking directly to the kernel. So there is no separate guest operating system running inside a container. Every application is running as the init process, or PID 1. Okay? So that's why, wow, containers are great, right? No, we can't really get rid of virtual machines, because right now the virtualization is still recommended to use for security purposes, to make sure that the containers do not, that if you have different tenants, that there's no, there's ways to escape from a container. If you mount the Docker socket in the container, it's very easy to escape from a container. There's some people like to mount the Docker socket into a container to achieve certain things within a container, but it has a security concerns. So the recommendation is still to use virtual machines to run your containers on top of it. So you provision your virtual machines or your droplets on DigitalOcean or your EC2 instances on Amazon, and then you inside those you run your Docker containers. Okay. Also recently, Intel announced another minimal operating system which is purely focused on running containers, which is called Clear Linux. Clear Linux is a way for Intel to highlight their virtualization technology and also to use it to isolate containers. So right now we have a couple of operating systems that are focused on running containers. There is Rancher OS, there is Core OS, there is Red Hat Atomic, right? And they're all focused on running Docker, on running bulk of the work within containers. Intel announced another one which is called Clear Linux. So that's that. Okay, so that was the whole Docker for developer presentation. I have a lot more slides that go into very technical details of how exactly the union file system works and all of that. But before I'm going to go into that, I want to look at the Docker platform, right? There has been some changes. Like we mentioned, there was the announcement of Machine, Compose, and Swarm. Okay, before I go into Machine, Compose, and Swarm, just want to highlight that it's really based on a client, which can be running on Linux, Windows, right? So I am here on a Windows host. Okay. Let's go here. So if I do Docker version, right now I am running version 1.9 on my Windows host, and it's talking to my server, which is my virtual machine. If I do echo, okay, so this environment is configured to talk using this environment variable. Docker is going to talk to this local Docker virtual machine. So you can set that up. I did it manually, but okay, I'll go through these slides first. So when I do Docker run, the client sends a command to the daemon to start a new container from a certain image. When I do another container starts. When I set it to stop, the container stops, and that's it. That was just, I don't know, yeah, that was just some presentation about that. So next, Docker machine. So right now, I manually created a virtual machine with CoreOS. I manually, you saw me, I had to manually mount my host file system and things like that. So I had to do some manual steps. It's not nice. There is actually some tool to help you with that. Vagrant is a tool to help you with that. There's some other tools as well. But there used to be boot to Docker, but Docker has now gotten rid of boot to Docker, and they introduced something called Docker Machine. Docker Machine is a tool that helps you provision hosts either locally using VirtualBox, VMware vSphere, VMware Fusion. Hyper-V is also supported. I haven't tested it. Or in the cloud. So you can use Docker Machine to create a new droplet in DigitalOcean. So I have Docker Machine here. Okay, I'm running version 0.5.0 release candidate. Okay, let me just. This is what I did earlier. I have a DigitalOcean account. And if I execute, DigitalOcean gives you a command line tool which is called, also written in Go, which is called doctl. You give it your key, and it is able to talk to my dashboard. If you see what I had earlier on my dashboard, here. So instead of clicking create droplet, I can use this tool to create new droplets, or I can use Docker Machine. So let me use Docker Machine to create a new droplet. So I'm going to use Docker Machine, create, and I specify the driver is DigitalOcean.
and I want to have a new, actually I have a demo script for that. Docker machine. So first thing I'm going to do is I'm going to create a new DigitalOcean droplet, which is going to be in the region of Singapore. And the machine, Docker machine name that I give it is my production machine. So when I run this command, okay, so now it's creating a machine. Amazing. Okay, so you see the production machine now is starting. It's not yet ready, it's new. And as we know, DigitalOcean, it can take, I mean, it's very fast, right? But still takes time, right? It takes a minute or so, even though it takes about a minute normally, all right? So right now this production here, it's about 60 seconds remaining, 30 seconds remaining. So it's creating the droplet. So I didn't have to do it manually inside the DigitalOcean dashboard. Just install machine and run the command, and it creates a droplet for you. It can also create your local environment for you. And you can use Docker machine to manage it. So if I do Docker machine ls,
Why it's Ubuntu?
this is the default machine. I can if I go to the DigitalOcean driver, it's a correct Ubuntu image, the one with Docker inside. If I go to,
But you can choose.
yeah, you can choose machine, drivers. So I go to the GitHub repo, but actually if you go to the docs.docker.com, you can also see the same thing. I just like the repo because the repo right now is latest version, and the docs have not been updated yet, so I like to use this. All right, so here we have a description of the DigitalOcean driver and what it supports. So it gives you information. You can specify the image, you can specify the size, you can specify if private networking is enabled. You can do all of that when you create your machines. All right. Okay. So right now you see the machine is running. Then it was waiting for SSH to be available. Then it detected. Then it's provisioning the instance. So I guess it's connecting to it and it's running Docker install, or it's running whatever it needs. Like it's copying the private key into the machine, and it's doing all of that for you.
Can you create Docker machine in an existing droplet, or you have to create a new droplet?
I haven't tried that, but I think you would need to create a new one. Remember the concept of immutable infrastructure. You just, you know, your droplets are like cattle, right? Not pets. You're supposed to be able to just get rid of them and just provision new ones, right? The idea is that your droplet is nothing special. There's supposed to be not okay. Once you have your database, your data. Of course, you need to have your data persistent. So you will need to have maybe a set of droplets which are running a cluster file system, and then your Docker droplets all mount those automatically. So all your data is stored on a separate cluster, and your actually Docker hosts are, you know.
But in case of, let's say, your application use different kind of Dockers, like Nginx, PHP, and so on, and you don't want to create so many droplets for these small applications. So it may be useful if you have only one droplet and so many Docker on it.
You will have one droplet, and then you have many containers on it. Like you can run an Nginx, you can run a PHP, you can run an HA proxy that load balances across all of them, and so you can do that with your containers. So once you provision that machine, it's there. If you decide you want to upgrade Docker, I think you would provision a new machine, and then you would move your containers to the new machine. Okay. We will see also how to control like a swarm of machines later as well. As you see, there is here I have a swarm master and a swarm node. Right now, I haven't done more with machine right now than just created droplets. So feel free to go to the Slack channel that we have, and if you have more questions, you want to play with it, you just ask more there.
we are quite willing to support. Okay, so right now the Docker configuration has been set, and now the machine is ready. So if I ask him to tell me the environment that I need, okay, so you know that if I echo my current Docker host, my current Docker host is pointing to my local Docker, right? If I use Docker machine, I can ask him to generate a new environment variable that points me to this new droplet. So Docker machine also helps me configure my client to easily set up my environment to talk to the new one. So right now, if I Docker PS, it's connecting to my local host. I want to use the other one, the droplet in the cloud. Then I can use Docker machine and prod. Right now, yeah, the Docker that's provisioned by the machine is version 1.8.3. Okay, so I still have my 1.8.3 client. So if I use my 1.8.3 client, I can see that right now I'm talking to Ubuntu machine with kernel 3.13, and it's using the Union UFS Union file system. The name of the machine is prod, and the provider is DigitalOcean. So right now I am talking from my Windows machine to my cloud server. Right? Okay. So if I do, let's do Docker. If I do Docker run web, I will put it dedicated, give it a name, call it, and expose port 80. Is it 80 to 80? I think it's 80. Yeah. I don't remember. So now I'm going to run this one on this completely new machine that was just provisioned. Am I forgetting something? Maybe. Okay, so the first thing is going to pull it from the hub. Of course, that's going to take a while because he needs to pull the whole Ubuntu image. It's not going to take long. It's going to take, I don't know how long. Depends on the speed that the Singapore DigitalOcean droplet downloads it from the US Docker Hub registry. Okay, I'm using Windows. There's still some problems with the, yeah, my terminal. Right, okay, let's continue with the script. Follow the script.
Can you change hardware space?
Hard disk space? You can do like this. Docker machine. No, in DigitalOcean, if you want a bigger hard disk, you need to do a snapshot. Then you need to provision a new droplet and restore the snapshot. You need to provision a new droplet, the biggest. So I think you can, in the driver, does it allow you to specify a snapshot, a backup? I think it, yeah, no, this is digital backups. It should allow you to pass in a snapshot. And it doesn't, so do a pull request. Yeah, if you make a snapshot, then destroy the droplet, then create a new droplet with a bigger hard disk. Based on that snapshot, you will have a new machine.
As I remember, backups and snapshots on DigitalOcean is the same.
Is it?
Yeah.
I don't know. It's been a while. Okay. Oh, okay. So in the meantime, the new image has downloaded and it's running. So what's the IP of this machine? I could. Okay, the IP is here. So this is the completely new droplet. And I just deployed my very simple web application on this new droplet. That was very fast. Okay.
I'm still using doctl to do fun stuff. Okay, so yeah, the new droplet is there. It's active. Docker machine also gives me the ability to SSH into prod. So, bam. Now that I can see that the container is running there. So Docker machine allows me to SCP files locally to the cloud. So if I do echo test foo.txt and I do docker machine scp prod, I think I need to specify foo text to prod, and let's say put it on the root foo text. Okay, copied. So if I go into my SSH and I cat prod, cat foo, there it is. Okay, so I can use Docker machine to to work with my droplet in the cloud. Okay, cool. Or I can do the same with my local environment. So yeah, that's it. Next, Docker Compose. Docker Compose is a tool that you can use to bring up a whole stack. Like the application so far I've been using is a very simple, just one Nginx static HTML. If you have a more complicated application which has, for example, this is a Python application that is running against a Redis, I can use Docker Compose to bring that up. So actually I should follow my demo script. What have I done? Okay, I can SSH, I can copy the files. Next, Docker Compose. Oh yeah, Docker Compose is only supported on Windows since now, since like recently. This is still a release candidate on Windows, so it's not stable yet. But I can go to my project folder, fundamental demo, and I can go to my training wheels. And in this training, okay, with Docker Compose, I have a special file called a definition. Again, this tells Docker Compose exactly what to do. So first, it's based around the concept of services. So the first service is the World Wide Web service, www. To serve or to create a container that is this kind of service, it needs to build whatever is in the www directory. This is my www directory, okay? So whatever is in there, that needs to be built first. Then, whenever it starts, it needs to expose the port 5000 within the container to the host port 8000. Okay? So it's going to expose port 8000 on my host. And it's linking to the Redis service. Okay, so this is my www service, and here I have my Redis service. The Redis service, I don't build anything. I'm using a pre-built image, which is the Redis image from the Docker Hub. The Docker Hub has a lot of officially supported images. For example, Node.js is there. Redis, Postgres, Python, all with different versions. I can use the Docker search command. Maybe I need to log in, but let's try. If I search for Node.js, okay. Let me go here in my local Docker search. For example, I want Node.js. There are some parameters I can provide. But from the command line, I can see that there is a Node.js which has a lot of stars. There is a Google Node.js. There's supposed to be an official one, which is, I don't see it here right now. But okay, the Docker Hub is public, right? So you have to be careful. I mean, whatever people push there, you wouldn't just pull and run whatever is there on your servers, right? So whenever I'm looking for an image, like I want to run Node.js, I need to look at first, has a high pull. That's not a good one. It's probably not Node.js, it's probably just Node. All right, there, that's an official Node image, sorry. Okay, so right now the official Node image has all of these tags. So if I want to run a specific Node version, I can pull specifically Node version 0.10.40. If I don't specify, I will pull latest. This is this one. Okay? If I don't specify the tag, it will just pull 4.2.1. That's currently tagged as latest. All right. So the Docker Hub has a lot of images. Ideally, have a look at what people put in there. This is a Docker file. Because a Docker file is such a simple format, it's easy to understand and have an understanding of what's going on. Easy. They use a lot of tricks here because every time you run a command, a new layer is created. So they try to do everything within one run command. This allows you to have a very small layer. So for example, they will do an update. Did they? The cache an apt update? No, they don't. They're just curling in the whatever version. And actually they're using the build pack Jessie. So they already have a special image that they use. And on top of that, they curl whatever is required. And they do the installation. And then they immediately clear it, the cache. Because if you don't, then the whole cache will be stored inside the layer. So if you do the Docker run 1 to do the install, and then you do a second run to do the cache clear, then you will still have a very big image. Because the first layer will have the full cache, and then you have a second layer where you remove the cache. So there's no point, right? So if you want to make small images, you should try and combine steps together. Of course, you have to do it smart, like where do I know that I want to be able to use the cache? If I know that something is going to change a lot, like my source code, if I'm building a Node image and I'm putting in my source code, I know that my source code should be the last layer because that's going to improve my build speed. That didn't explain why I should combine steps though. But combining steps helps you make smaller layers. Okay? There's a lot of other ways that you can make very small images. For example, a fun one, but this is very detailed. Okay, so for example, this one I use. Okay, so I have this image here that I made for my environment. I need to have the mount sifs binary, and if you build a binary, it uses a lot of things that I don't need. So I just compile the binary with static links, and then I just push that binary inside another machine. So you can see my repository. Where's my repository? Well, right now this is just a 4.7 megabyte. So you can really make them small if you do your best. Where am I? Well, yeah. If we go, all right. How did I end it there? I thought that would. So I have my mount sifs image here. So I have two Docker files, and in my build script, what I do is I first build my builder, and then after I build my builder, I pipe the output of that builder and I pipe it into my second image. So I'm using some tricks to build a new binary, and then I'm sending that one to the standard out, and then I'm piping it into another image. So I'm building from one to the other. So yeah. I'm using BusyBox, which is a very small image. I'm not talking too much about that. I'm talking about Docker Compose. Why? Okay. Yeah, I was talking about the hub where you can find images that you need to watch out because anybody can push whatever they want, and it's good to have a look at how the image is built. Maybe they made some mistake. So sometimes it's better to build yourself. Obviously, if you're a developer, you just want to focus on your application and not play around like I'm doing all the time. Okay, so what I want to do now is I want to go into my in my training wheels application, and I want to use Docker Compose to remember this is talking to my this is not talking to my Docker machine and prod. Okay? No, I don't want to talk to that. I want to talk. Let's talk to my local Docker. No, that's not going to work because there's no local Docker. So I'm just gonna okay. Unset Docker TLS verify. I'm not using secure connection to my local machine, so okay. So now I'm talking to my local machine, and I'm gonna do Docker Compose -d. So with Docker Compose, I can just use up to start up the whole stack. So what this is going to do is it's going to read this Docker Compose file, and it may give me some errors because on Windows it's giving me some weird errors earlier, but maybe not this time. Okay, so the first thing, it doesn't give me errors this time. So it's pulling Redis because in my compose file, it says that it needs Redis, right? So the first thing Docker Compose does is pull the Redis. It's going to start it up. Because I didn't specify what version of Redis I'm pulling, so he's always pulling the latest. I may already have something on my local Docker, but I didn't specify the version, so he's just pulling the latest one. Not good. I should version pin. It's actually, it's doing stuff. Yeah, it's a little bit buggy on Windows. Don't know why. So with this one command, I am now starting all the containers required, building and starting all the containers required for this application. So imagine that you are a developer and you just come to a new company, and they ask you to start working on this new on this project that they have. So you didn't even know what language they're using. You can just go in, git clone the repository, and use Docker Compose to just up the whole stack in your local environment. No problem. You don't need to install, you don't need to research they're using Node.js, you don't need to install the version, do the package management, do the whole thing. You just have your virtual machine with Docker, you do Docker Compose up, and you're good to go. So that's what happened here. Docker build was done. It created the training wheels Redis, and it created the training wheels WW1. So if I Docker ps-h, I have training wheels running. It's listening on port 8000. So if I go to my Docker, local Docker, port 8000, there it is running. So every time I press F5, it keeps going. So this training wheels application is something that Jérôme Pétazy did a demo on in Amazon AWS reInvent. He did a very nice demonstration on how you can use Docker Compose to auto scale, how you can use it with they call it ambassadors, right? Load balancing ambassadors. So to do linking across hosts with load balancing ambassadors. However, I didn't have the time to do the whole demo preparation because I would like to demo it with Swarm, where you don't need to worry about that, about the ambassadors. But really recommend it to search YouTube for Jérôme Pétazy's presentation on reInvent. I think if you do reInvent Jérôme. I don't know how to write. Jérôme. I think I wrote it wrong. Pétazzoni. Sorry, man, I'm totally butchering his name. Docker from development to production. Docker development. From development environment. There is a video. This is his presentation, but if you search, there is a video on YouTube. I probably need to search on video. It's not this. Okay, search for it on YouTube and you'll find it. Not wasting more time. All right, next. So we've seen Docker machine to provision machines, either local or on the cloud. We've seen Docker Compose to bring up a whole stack. And now we're going to have a look at Docker Swarm. So Docker Swarm is a tool that allows us to... So I did the training wheels, I did the Docker Compose up. Let's go next. Docker Swarm. Okay, so I've already done the setup. I have used Docker machine to provision me with okay, I have a swarm master and a swarm node. Yeah. What does it do? Okay. Swarm allows you to talk to a cluster of machines, and it makes it look like you're talking to just one Docker daemon. So what happens is when you point your Docker client to a swarm, which I do with this command. So what I'm doing here, I'm asking Docker machine set up reconfigure my environment to talk to the swarm master, and I'm actually want to talk to the swarm. So I want to talk to a swarm, and if I do invalid certs. What? Why? That's gonna mess up my demo. Let's hope it works. What happened? Sucks. Okay. So yeah, once I point my Docker client to a swarm cluster, I can Docker run, and Docker Swarm will automatically schedule the containers to run on a available machine within the cluster. When it does the scheduling, it currently supports only two strategies: either spread or all together, like minimize the spread. By spread, it tries to run each container on a different node. So it tries to spread all of the containers on different nodes. So if one node goes down, no problem, only few containers went down. Okay. When you do focused, I don't exactly know the right term. Let's call it no spread. Then it will focus. I think it's called bin pack. Or no, I don't know that. It will try to put all the containers on one node, and when that node's full, move to the next one. Okay. So it has only two scheduling methods for you, or scheduling strategies for you. It currently does not do self-healing, or it does not do much of service discovery. But what it does do in the new version is it allows you to create a network connecting all the containers across all the hosts. So you can easily, and it also adds the containers into each other DNS entries, so they can find each other without service discovery. But you still need load balancers. So what Swarm does right now is not much compared to Kubernetes or Rancher or all the other orchestration frameworks. Last time we were here, we were doing a meetup about Rancher, and we showed how Rancher does a lot, but Swarm doesn't do all of that yet. But it's going there. It's getting there, I guess. Shit. Sorry. That's not cool. Why? So is that gonna mess up my whole demo? Yeah, if that's not working, then shit. That's not good.
Well, you would run a swarm if you need
high load and you want to spread that up.
Yeah, so if you run Docker by itself, the containers are isolated on the host. So once you start growing bigger, you may need to, if you have, for example, WebSocket servers, and you start to get a lot of traffic, you want to scale those WebSocket servers. So you may need to run multiple containers, and then you may start to run out of space on that one host. And then you want to be able to run a separate Docker host, and then run those Docker WebSocket containers there. But then you have the problem of cross finding the containers. So then you need to make some kind of connection between the nodes. And Docker Swarm does this automatically.
So nodes are just hosts.
Yeah, when I say nodes, I'm talking about Docker hosts within a swarm. Yeah. Okay. I'm afraid that my Docker Swarm demo is probably not going to work. I'm very sad because
You can create new containers.
Yeah, but to make the demo work, I want to have Swarm version 1, and if I create a new container, it's going to create Swarm version 0.4, which does not allow me to create networks, overlay networks. And I had the whole overlay network thing working and everything, but unfortunately.
I found that your image is
I don't know what happened. When I was testing it earlier, it was fine. I should have recorded the demo because I thought that everything would work. So unfortunately, I won't be able to show much Swarm.
Maybe your interruption happens
Limits?
is possible, because sometimes I have the same issue. I try to open new droplets and
But
please submit it.
they are there already. I created them earlier. I could try. Earlier when I tested it, everything was working, so I haven't been able to actually. Right now, I meet a problem. I cannot demo. It will take me too long to find out exactly what's wrong and fix the issue.
Do you have backup source? Do you have backup source snapshots?
Nope. I just managed to finish this like 1 hour before this meetup, and I didn't make any snapshots. So unfortunately, I can tell you what my demo was. My demo was to talk to the swarm, create a new network, then start all of the containers randomly on the different Docker hosts, all connected to the same network, and then they could ping each other without any problem. Yeah, you have a question? Or say bye-bye. All right. I'll record it and I'll put it on the YouTube channel, and I'll post it in the meetup once I got it working again. So anyway, we're reaching close end of the meetup time, right? It's from 6:30 until 8:30, is it? Yeah. So I only have 15 minutes. So Swarm, unfortunately, I will have to do later. Okay. Next. So all of these three tools, Machine, Compose, and Swarm, you can install them all automatically by using the Docker toolbox. When you use a Docker toolbox, it also gives you Kitematic. Kitematic is a user interface, a user-friendly interface that allows you to search the hub and spin up stacks of containers and things like that. I don't use, as you see, I'm not using the UI. But if you want, you can try it out. Okay. Sorry? Kitematic still beta? I don't know. Okay, so the whole point of doing the meetup today was to get a scoop on version 1.9. Version 1.9 adds new network commands. With the network commands, you can just do docker network ls. And if I had who am I talking to? Wait. No. Okay, I'm talking to my CoreOS. I'm talking to my local Docker. So my local Docker, I can do docker network ls, and it will give me all the networks. So by default, there's the no network, host, or bridge. If you start a new container, it's connected to the bridge. all the containers are connected to the bridge and are isolated from the public internet through the host. So you need to map ports on the host to connect to the containers. You can create new Docker network create, and you can say I want to create, for example, a new bridge network, and I specify Docker create with the driver bridge, and then I specify the name, for example, local bridge. Okay, so Docker network. So now I have a local bridge. So when I do Docker run, I specify net local bridge okay. So now I'm running a Ubuntu image which is connected to the local bridge. So I'm connected to ETH0 on 172.18. If I create another to the same bridge, okay, so I can see what's inside the host file. I can see this admiring pasteur on this 02, that's this container. So these containers can see each other. They are isolated from any other containers. So if I'm running other containers not connected to this bridge, those containers will not be able to communicate with these two containers. So the Docker networks allows you to isolate containers. There's also, I can Docker network inspect this local bridge to see all of the containers that are currently connected. So I have one container connected, and that's his IP. When I run the second one, I exited it, so it's not running anymore. If I run a second one, it will be connected to the same bridge. With the Docker network, I can create with an overlay, with the driver overlay. The overlay network driver is still experimental today, but with version 1.9 it should be no longer experimental and should be production ready. It's the type of network you create to go across different hosts. So it's difficult to show if I don't have a swarm cluster. So unfortunately my demo was to create an overlay network and then to start up containers, and they would land on different hosts and then just ping them each other. So that was great, because before this version it's not possible. You can only do this with Kubernetes or Rancher. They provide things. You need to set up your own overlay network with Flannel or Weave or Docker. Rancher uses something else. They use IPsec kernel kernel overlay networks. So right. And when we do Docker Compose scale over the swarm, then we should, the first thing also is, with this new version, you don't need to specify links anymore within a Docker Compose, because automatically they can find each other. Right now, if you make a Docker Compose file, you have to specify how the containers talk to each other, which ones are linked to which. But if you are doing with a network, you don't need to do that anymore, because they can automatically discover each other.
How would you define inside the World Wide Web container, for example, the connection to the Redis container? What would you pass in your Python script so it knows?
Yeah, okay, so what you would need to do is you would need to run a registrator. So when your Redis container starts, you may have a companion container which is hooked onto it. You can do companion containers by sharing the same network interface, and then you can they can communicate over localhost, and he can find the IP of the Redis and announce it to like a distributed that service discovery. So you would still need to use the service discovery to find the running containers. Yeah, but you don't need to define with Docker Compose the links.
Okay, but you still need to give it a DNS name, sort of.
Yeah, there are some tools that that listen for Docker daemon events. So when the Redis container goes online, it may have a label, and then you have like some tools that listen to the Docker daemon and see that a new container has been created. They will see, oh, it has the label Redis. They will automatically register that with a load balancer. And so your Python application would then be configured to talk to the load balancer, and then the load balancer will balance across all of the Redis containers. There are several tools. There's one called Docker Registrator or Registrator. There's another one which is very cool, which is doing exactly what I just said. It's looking at the Docker events and then automatically creating an Nginx load balancer. So you can run, if you make a website and you specify the host name, then that tool will just look at, oh, this is the host name. It will just add an Nginx entry to make Nginx forward whatever comes in to Nginx to that host. So you can do that for local development if you're working on several websites. Then you can create Docker containers with environment variables in it. Now you should use labels, not environment variables. But before there were labels, you were using environment variables, and then you have other tools inspecting those and doing load balancing across those. But yeah, as you hear what I'm saying, it becomes very cumbersome, right? You need to do a lot of setup. You need to set up a lot of tools. So if you use an orchestration framework like Kubernetes, it does all of that for you. So Kubernetes is a whole different story. It basically helps you. It already has a load balancer for you. It already does the self-healing. If one of your containers dies, it automatically spins up another one. It automatically registers it with a load balancer if you define a service for it. So it does all of that for you. And these new features are going to help tools like Kubernetes, I'm thinking. Right? Next version of Kubernetes is going to use Docker Swarm networking, maybe overlay networking to ease the way that Kubernetes works, I would assume. But we're not there yet. But right now, before version 1.9, you can already use Kubernetes with version 1.8.3, and you're good to go. Okay. All right. We're almost close to the end. I wanted to say a little bit more about the concept of these layers. Yeah.
Docker 1.9.
Yeah.
So we can feature the usual already.
Sorry? Swarm? What about 1.9?
You show all the features.
Those are all the features? Those are the features that excited me the most. Just a second, let's see.
I don't know if I actually interrupt.
No, go ahead.
Do you know about the build args?
Build what?
Build arguments?
Build arguments?
Yeah.
They're what do you refer?
It's a new feature of the 1.9. So build arguments. So you can parameterize a build.
I've not seen that. Let's see. So they improved the Docker stats. They added the stop signal. That's interesting because before, when you do Docker stop, it sends a certain signal, which is the sig. What is it? Sig term, and some processes don't listen to sig term. So if you do a sig term to Nginx, it shuts down, not gracefully. So with the new Docker version, there will be a stop signal, so you can specify Nginx requires to have a sig, whatever, another one, and then Nginx will gracefully shut down and keep the WebSockets open until everything has been closed. So there's a stop signal, and also they add the ability to, in the Docker build, in the Dockerfile, specify which stop signal the image should take. You talk about build arguments. Okay. No. Yeah, builder here. Stop signal. Arg. Add an arg Dockerfile instruction and build arg flag to Docker build that allows to add build time environment variables. Okay, so you can because this is a problem when you do a Docker build. If you have a Docker file, it doesn't take the environment variables easily. No, right?
It doesn't.
It doesn't. I think what this. I'm not sure about the whole functionality, but one issue is the
Docker build.
Another issue I think affects a lot in the NAM is that, for example, you take from a Ubuntu image and you take the source from apt-get from a server in the US. So sometimes, the server are hitting internet here, so it's so slow, or maybe you get an invalid checksum because the servers are replicated also.
Right.
So you will have to wait a lot.
Okay.
So with this, you can put basically an argument. It's going to be like a source that you can choose.
Okay.
And then you can put the apt-get source from the NAM faster.
So you can use the build args, I'm going to repeat, for specifying, for example, sources closer to where you are. So when you do your apt-get update, you're not fetching packages from the US, you're fetching them locally. And that's better. Yeah. So you avoid build failures because of internet problems, right? That's interesting. Cool. I haven't played with that yet. Thank you for bringing it up. I didn't pay attention. To me, the coolest thing was like the overlay networking, because I'm right now have a Docker host and I'm looking at creating more nodes, and I want to be able to have containers communicate to each other. And I'm thinking of deploying Kubernetes, but then I think it looks quite heavy. So I'm really interested to try this overlay networking built into Docker, and with Docker Swarm. But I think right now it's not 100% yet. So, but it looks very promising. Yeah, the Docker networking is big. They added new log drivers, right? Okay. Yeah. They didn't specify. Here they didn't. They do here. Okay. So I skipped it. Right. Okay. So it's 8:30. What do we want to do? Do we want to have a look at how these layers work? Like how that works when you commit an image? Is that interesting? No? Some people say no. Okay. So this is very technical. So when you do a Docker run, so you start from a Docker image. Inside the image you have your file system, and when you do Docker run, it spins up a container which has a scratch layer or a writable layer that has only pointers to the other. To only pointers to the image. So whatever you do within that container is all happening on the scratch layer, and if you create a new file, it is actually created in the scratch layer. So once you commit a Docker container to a different tag or to another image, then you will have a new image. In this case I called it Docker commit with a tag called layer 1. This is pseudo Docker. And I have a new scratch area where it's read-write. So whatever the images are that build up a container, they are read-only. And whenever you run a container, there's a separate area created for you to, or a separate layer added on top of all the other layers where you do the actual writes. So once we're finished, the new container started, then the new container built based on layer 1 will point to all the layers before that. So that's a little bit how a union file system works. I saw this slideshow from Microsoft explaining how they implemented the union file system on Windows with the NTFS, and I thought it was a really nice visualization. Actually, like this week, somebody else also made a very nice explanation and visualization of how the layers work. And if you want to look at that, you can go to the Docker newsletter or go to the Slack channel, and you will find some message about that. And that's the end of my slideshow. So, questions? More questions than before, or some people do? Okay, you go first.
Okay. Yeah. So if I I'm running a Python application and I make a couple of commits in my GitHub, and I want to deploy a new version, but it doesn't require any environment changes. What would you completely update your Docker file to check out the new Git tag and deploy a new Docker container, or would you SSH into the Docker container and just?
Sorry, my Docker file to deploy the new Git tag.
Well, I only have to update the source code of a running web application.
Okay, so you would need to rebuild the container and redeploy a whole new. Rebuild an image and push the new image to the server, and then start fresh containers from that image.
Okay.
Right. This whole concept is, of course, you can do some tricks. Like you can have a companion Git puller container, which is a container which runs an application. All it does is it pulls the latest source code from Git and it shares the volumes. So then you have like an Nginx which is reading this static data. For example, you could do that. Is it a good way to do like that? Maybe good for development, but I don't think you would do like that for production. It really depends on what you need to do, right? I mean, anybody wants to add something onto that? Feel free.
When you commit to the new image, does the old data from the original one will copy to the new layer, or?
You mean like this is the original image, and you commit to a new image, right? So in this new image, it only has the difference. This is pointing to the previous image. The only difference is this file. So all of these files are not inside this layer. So this layer will only be as big as this file, for example. So the new image is a combination of both layers. Yeah, it's a union combination, right? Set theory. And that's what, without this file systems that provide the ability to do copy on write, Docker would never be able to be fast like it is. Before, Linux containers were there already, but they were slower because whenever you created a new Linux container, you had to copy the whole file system, then start a container on that file system. What Docker did is they added a way of using a copy on write system. So they don't copy anything when they start the container. They just, bring up the container with pointing to the existing layers only as readable, and then having an additional layer where you can write. So whatever you do in that container is only written in that layer. If you commit your changes, then only the changes are committed as a new layer into a new image. So you get very small layers. And so when you are pushing your images across the web, they can reuse existing images. If they are 2 layers, they have a hash. They are signed. You know what I mean, MD5, whatever. They can be verified that they have not been changed. So once 2 layers are the same, they will they can push only the differences. So normally pushing images across should be quite fast, right? Should be quite fast.
If I have there are many layers,
Yeah.
to remove some.
Yes, there are. You can Docker squash, I think. There are some tools that help you. You can Docker export and squash layers. There are tools that you are able to recombine layers. Yes, I've never used them myself though, so I don't know much about it. Yeah. Anything? You had 3 questions, or?
Yeah. For example, if I create container with my SQL, and I want to mount a folder where I store database.
Right.
Do I have any overhead in this case?
I think the
because
volume.
sometimes database is bottleneck and it.
I think the volume is mounted. If you do a volume mount from the host directly,
Yeah.
there should be no. There's you are going around the union file system. If you use a union file system, there will be overhead because whenever it writes, depending on the union file system or copy on write file system, it may need to copy a whole block of data before it can write into the new layer, or it may need to copy a couple of files. But if you're mounting a volume, you're not using the union files, the copy on write file system. So you're actually talking. I think should be no performance hit. I think. Right. 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 It's true that there's two approaches here, right? I mean, regarding the earlier question about code changes, do we want to have like a companion Docker container that pulls the code changes? Does that make our images not immutable anymore? Yes, I think they do. And I think if you're looking at the concept of immutable infrastructure, you should strafe for. You should try to get immutable infrastructure. Of course, I don't know how much that is applicable in a production environment because my right now production use is very, very small, very simple. We rebuild every time we have a new version, and we use load balancing to move to the new version. So, okay, good, thanks.
One more question. Do I have any solution to inherit Docker file? I mean, I have one Docker file for PHP and a second Docker file for Node.js.
Yes.
But sometimes I need a container with PHP and Node.js, for example, to build my system, just for build, not for run. And in my build script, I need PHP and Node.js. And I don't want to copy-paste PHP part from PHP Docker file and Node part from Node Docker file into one file.
And then keep them updated?
I need to maintain.
Right. What you're saying is if I have a Node.js Docker file that's officially supported and a PHP Docker file, and I want to have an image where I have both Docker and PHP together, Node and PHP together. Right now, I don't see an image in the hub, so I would need to maintain my own, and every time there's an update, I need to again merge. And well, I haven't faced a scenario yet where I need to have both environments. Does anybody else have experience with that, or?
For example, I use Composer and I need PHP.
Yeah.
Because of that, and in this Composer, I have some work for Node.js.
Yeah, but wouldn't your Node.js be a separate container running outside? So then you would use Compose to link them together?
In this case, I should change my build file.
You should change
to work with remote Node.js.
Yes, that's right. You need to change your application in that case. Your application needs to be built more. It's basically your application becomes more like microservice-like, right? I mean,
yes, but I'm talking only about build my application. Something like include part of Docker file.
Oh, so
I
you
know
use
that I can make.
In your development environment, you have you use a Node, maybe some Node packages to do some work from like Grunt or Gulp or whatever.
For example, I need Node.js to build CSS from less files.
Right.
In the same build process.
You're right. I would. When I set up my, I have a similar environment. I mean, I had Node and Python, but I from the start made it that I have one Python, one Node. Yeah. And I mean, my Node was purely for building generating the stuff. But there's actually, you can use containers in development environments. You can kind of use them like virtual machines, except that you can't really run more than one process within it, or you need to run a supervisor and things like that. But if you use you Docker bash into your Ubuntu container, you can apt-get install your whatever you need for your environment. You can apt-get install your Apache, PHP, and your Node.js, and then volume mount your development things, and build, and then commit that image. This is my development environment that I work with. It has Apache version this, it has Node version that, and it has PHP version X and Compose Y. So it's like your virtual env if you were using Python before. So you have this virtualized, your isolated development environment, and for projects that you need these versions, you use that image. Then you can use it, and then if you have to upgrade to new versions, you will need to create a new one, right? And then if you have people that in your development team need to all use that image, it becomes difficult. You need to maintain the Dockerfile, but is it that much work? Is it to merge them once? I think once you started a project, your versions are kind of stable, aren't they? So once you start, okay, we're going to start with the PHP and this version, that version, and then the whole project, that version is not going to change often.
Yeah.
Right. So then you're working in your development environment and using your, then you're good to go, I think.
Yeah, but sometimes I can forget about the changes in my build. Okay.
But then it's fine. You have a new image. Like, okay, now we need to have a new. You know that for this project we use this version, this image, and everybody's using the same image. Everybody has exactly the same environment. When a new developer comes, he pulls the image. He's gone. He's good to go, right? So then you decide to upgrade. Okay, guys, you make a new Docker file. People pull the new image and good to go.
The last question is about if I use Mac and I want to get two environments, the same environments from the same Docker Compose file, I can create second Docker machine and run it there. I have two similar Docker machines.
Yeah.
But if I use Linux, should I use Docker machine 2 or?
What do you want to exactly in your Docker machine that is different? Because you have, what is it, a different Docker version or a different Docker Compose version? What's the different version?
No,
if you're on Linux,
I get my project and I want to build environment where I run it.
Does someone else want to ask something? I think it's fair if we share.
Yeah.
Actually, I'm gonna have to go.
Okay. All right. Yeah. Okay. So, yeah. Thank you for your time. I'm sad that the Swarm demo didn't work. I spent like crazy to make it work, and I was like, yes, it works. And then I come here, certificate invalid. What? Yeah.
Is Swarm actually like Docker Compose, but between different?
But across multiple hosts, yes.
Yeah. The same word connects. It helps to connect.
Yeah.
Thanks again.
Yeah. Thank you for coming. Nice to see you.
Yeah, try to come and bring up the great presentation. Did you record it?
Yeah. Oh, it's actually still running. Yeah, it's okay. Just close it. I'll just close the stream once.
So